This is Aaron's arrays. Aaron is setting up an array to solve 2.5 times 4 1/4. Fill in the blanks on the array. So we have 2.5 by 4 1/4. So I see 2 down here. So this is, or 2 1/3. Sorry, did I say? I keep saying a half. And I have 4 1/4. So this area would be 2 times 4, and that's going to give me 8. Here's a third times 4, which is 4/3, or 1 1/3. This one is 2 times 1/4, which is going to give me 1/2. You think about that, it's 2 quarters, 1/2. And here we have 1/3 times 1/4, which gives me 1/12. So here we want to add everything together. We have 8 plus 1 1/3 plus 1/2 plus 1/12. Let's see, thirds, halves, and twelfths. Those all have, I can make those all twelfths. So 1/3 is 4/12, and 1/2 is 6/12. So we have 8, 9, 6, and 4 and 6 is 10, and so 9 and 11/12. All right, Aaron needs to solve 1 4/5 times 2.5. Sketch and label an array that shows that. So we have 1 and then 4/5, and this is 2 and 1/2. So this is 2 times 1 equals 2. We should put 1 first. 1 times 1/2, which is going to give me 1/2. 4/5 times 2, which is 8/5, which would be 1 3/5. And 1/2 times 4/5 is 4/10. So looking at this, these are all going to be tenths, right? Because I can turn fifths into tenths by multiplying by 2. I can turn halves into tenths by multiplying by 5. And we have 2, so I have 2. 1 and how many tenths would that be? 6/10. Plus 1/2 in tenths is 5/10. Plus 4/10. So here 4 plus 5 is 9, plus 6 is 15/10. So that would be 1 5/10, or 1 1/2. So 1 and 1 is 2, 2 and 2 is 4, 4 1/2. Fill in the blanks. 3/2 times 14 is the same as, we're halving and doubling. 3 1/2 doubled is 7, so that's 49. 32 times 2 1/4 equals 16, so I'm halving 16 and doubling 2 1/4 to 4 1/2. And that equals 16 times 4 is 64. Half of 16 is 8, so that would be 72. Oh, I guess I could have done 8 and 9 too. Right, 16 times 4 1/2, I could have done 8 times 9. That would have been pretty good. 24 times something equals 12 times 15. So 7 1/2. 12 times 15, 30 times 6, 180. Solve. Use the strategy that makes the most sense to you. Ooh. This is some thinking here. I mean, I just never feel they give you enough room sometimes. Don't you ever get that? No? Alright, here we go. So I'm adding. I could do some strategies where I'm rounding, give and take. Let's see, if I give 4, I would take 4, so I could make it 49.1. Let's do that. $103 and 1/10. 27.25 times 16. Yeah, I guess I'm going to do the algorithm, but look, it's teeny tiny for the algorithm. 16. All right. 6 times 2 is 12, plus 3 is 15. 6 times 2. Oh, I didn't make a prediction. I know 27 times 10 is 270. 27 times 20 would be 540. So my answer is going to be, what, in between 540 and 270 is like 300, 400? 400? So I'd say around 427. 430 would be my predictions. I'm going to predict. Let's see. Where was I? 630. 6 times 2 is 12. Plus 3 is 15. 42. 6 times 2 is 12. Plus 4 is 16. And then we're really multiplying by 10. See here, I would just want to do. I guess it just doesn't matter. 2, 5, 2, 7, 1. Wait, what? 2? 5, 2, 7, 2. 0, 0, 4, 6, 13, 436. So that was right around my estimate. That was a pretty good estimate. Brushing off some stuff. Alright, I'm subtracting. I really don't like when I have zeros up top, so I'm going to drop this down to 29.99. So that means I have to drop this down by 2. Or 2 hundredths. Oof, what a misspeak. So again, this is the constant distance strategy. 9 minus 7 is 2. 9 minus 4 is 5. 9 minus 6 is 3. So 3 and I should have estimated, sorry. Always gotta estimate. 62.5 times 24. That's gonna be around 1200. Like 1400? 1500? Be around 1500, I think. Alright, 62.5 or 62.5 times 24. Is 24 anything special? 25 is a quarter, right? But 24, I don't. I don't know. You know what I like doing? I'm going to do it up here. It says I can do whatever I want. So whenever I have 1, I have 6250. So I know that 10 is 625, which means 20 is 1,250. Double this, which is 2, is 125. So 4 of those would be 250. And then 1,500. Killed it. I didn't do the calculation. I was just thinking. Ciao.